Okay, we are graphing sine and cosine functions today. So the thing about sine and cosine functions, they only go up. The highest value they can get is 1, and the lowest value they can get is -1. So no matter what you plug in, if you plug in like sine of 500 degrees or sine of 4 degrees, all those values are going to come out between -1 and 1. So when I do my little graph here, I usually spread it out a little bit because if you only go to 1, -1, it's really tiny. So I like to spread it out a little bit. I'm not going to say you have to, but that's what I do. And then I usually put 4 marks over here, and you guys are going to need to do that eventually. Put a few marks back here. I also spread these marks out a little bit to help, so the graph's not too tiny, basically. So if I plugged in, let's say we're graphing y equals sine of x. So the y value is based on whatever we put in for x into the sine function. If you plugged in like sine of 0 degrees, your calculator would say 0. So it kind of starts at 0, 0. Okay, if you plugged in sine of 90 degrees, your calculator would say 1. If you plugged in sine of 180, and so I'm counting by 90s, it would say 0. If you plugged in 270, it would say -1. And if you plugged in 360, it would say 0 again. All right, you guys see the pattern yet? So if I go -90 degrees, yeah, it's just, it's waves. -180, -270, and it just keeps going forever, like that. So it looks like this, it's very curvy. All right, so that is what sine of x looks like. Okay, the only thing is though, they don't usually on these graphs like using degrees. I don't know why. Don't ask me why. Why? They like using radians. But we're not really doing much with it. It's just, instead of like 360 or 180, remember 180 is worth pi, so 90 would be half of that, pi over 2, pi over 2. I'm not going to do much labeling of the x-axis, but basically this is what we're going to be using. Okay, now we need a few terms here. The first one is a periodic function. Do you guys know what the word periodic means outside of math? Yeah, something that happens like on a regular schedule, like over and over again. Oh, you guys have heard probably people use the word I periodically go to Tulsa, whatever. Walmart, yes. Anyway. So a periodic function is a function that starts repeating itself over time. So that would be our functions today. Sine and cosine are periodic functions. So if they say what is the period, that means how long before it starts repeating itself. So on this function, notice like right here at 0, it's at 0. How far do I go before it starts over again? Okay, right here. This doesn't count because the graph is going down right here. So right here is where it starts repeating itself. So how far is that? 2 pi. It's like 360 degrees, but 2 pi would be the period. So the period for a normal sine and cosine graph is 2 pi. How far does it get before it starts repeating itself? And you don't have to count from here to here. That's probably the easiest one, but you could do like from here to here. Like this would be, that'd be kind of hard. How far is it from pi over 2 to -3 pi over 2, like from hill to hill? You could figure it out by subtracting. That minus that would give you the distance. How far is it? It'll come out as 2 pi. So anyway, my point is there's different ways to find it. Okay, the other term, this is the last term that we need for today, is called amplitude. And the amplitude is how much the graph goes up and down from the middle. So the middle being like the x-axis in this case. So how much is the graph going up and down from there? It's going up 1 and it's going down 1. So the amplitude is 1. So for a normal sine or cosine function, the amplitude is 1. Another way to think of amplitude is it's like the height of the graph divided by 2. So the graph's height is 2, but then you divide that by 2 and that's the amplitude. Okay. Alright, let's do cosine. Cosine's almost the same. Very similar y equals cosine x. So the difference is that instead of, you guys remember where sine started at? Sine started at 0 going up. Cosine starts at 1. So if you plug in your calculator, like what's cosine of 0, it'd spit out 1. Cosine of 90, 0. Cosine of 180. Oh, by the way, I'll probably forget if I don't mention this right now. Was this the class where I made you switch your calculator to radians, or was that the other class? Must have been the other class. You guys don't know what I'm talking about. Okay, never mind. Keep going. Cosine of 270 is 0. Cosine of... So do you guys see the pattern? It just, for each step, it just goes another level. So it's top, middle, bottom, middle, top, middle, bottom, middle. Just keeps going up and down like that. So there's a reason why I split this into fourths. The period I put on the fourth mark, 2 pi, and then just I split it into 4, because each fourth step gets you another level. If that makes sense, hopefully. And that's the pattern. So top, middle, bottom, middle. Sloppy Joe over there. Okay. So cosine looks almost the same as sine, but instead of going through 0 at 0, it's going through 1. So if I shifted cosine over, it actually would be the exact same thing. But anyway, that's the difference. Okay, so that's y equals cosine. What is the period? Hilltop to hilltop, it's still from 0 to 2 pi, it's 2 pi still. What is the amplitude? Still going up, down, 1 and down 1, so it's still 1. So almost identical. Okay, we need to talk about a couple more things and we'll get rolling here. No. All right, let's see if you guys can guess. What do you think would happen to the graph if I did times 2? Any guesses? Eight. God forbid you're wrong. I'm just asking you to guess. I'm not asking you to know. Yeah, it is twice as tall. So, in other words, instead of going up to 1, it doesn't go up to, it's just, instead of going up to 1, it would go up to 2. Instead of going down to -1, it would go down to -2. And at 0, 0 times 2 is still 0, so it would still be there. So kind of like that. I didn't draw that very great, but you guys get the idea. All right. Twice as tall. That's what it does. So in other words, what's the amplitude on this blue one right now? 2. So the number in front is the amplitude. And if there is no number in front, then the amplitude is 1. Okay. Let's do a different color. What do you think will happen? This is kind of just based on other graphs we've done. Like, see if you can guess what will happen. What do you think will happen if I throw a negative out there? Upside down. Yeah. So instead of being up at +1, it'd be at -1 right here. 0, the opposite of 0 is still 0. Instead of being at -1 right here, it'd be at, yeah, it's just upside down. So red was the original, this is, okay, there's one more, this one's actually the hardest, but hold on. What color do you guys want?
Purple,
Yellow.
Okay, I heard two purples, so we'll go with that.
Bro.
So one time, Hope doesn't ask for purple.
I wanted yellow.
Yellow does not show up very well.
Orange, green, blue.
Hmm?
Can we do a better green?
Yeah, blue, brown.
Like an actual good green, please?
No,
Can we please?
we're sticking with purple. Okay, so this is like the last thing. Another thing that could happen is they put the 2 on the x variable. Okay, this affects the x, I need my motions to be on camera. This affects the x direction. Basically what it does is it makes everything happen twice as fast. So it's a horizontal squish, compression. Used a fancier word than me. A horizontal squish, like an accordion. So instead of, this graph's getting kind of busy.
You should do orange so it stands out better.
If you make it yellow, it would be great.
Okay, I don't think the color's gonna matter, there's just a little bit too much going on. Okay, so in other words, instead of going all the way out here before it starts repeating itself, it will only get to right here. The period, which is normally 2 pi, is going to be divided by 2. So basically you just do the normal period 2 pi divided by whatever number's right here, and that gives you the new period pi. So, let's see, we're doing cosine, aren't we? So I've got to get like down and up and down and up twice. Okay, so it's a horizontal compression. It goes through one period just by the time you get to pi. Alright? That's it. So you got it? If there's a number in front, that's kind of easy. It's just twice as tall, or 3 times, whatever the number is. It could be a half. It could be half as tall or whatever. That's the amplitude also. The negative flips it upside down. And if there's a number right here, the new period is going to be 2 pi divided by whatever that number is. So in my example, the new period was pi. Alright, okay, I think we got it. Now, I didn't say this, but number 1 and 2 I just did like 5 minutes ago.
What's your favorite animal?
Let's see. So, I'm sticking with purple, I guess.
I thought we did a giraffe.
Number 1 is we're supposed to graph y equals sine of x. I think they use the variable theta. It doesn't really matter what variable it is. Theta or x is still this axis. Okay. So, do you guys remember where I started at with the 0? 0 going up. And also I kind of split this into fourths. And the fourth one, I marked my period out there as 2 pi. And let's do at least a couple, 2 or 3 going backwards. Okay, so sine starts in the middle going up. So top, middle, bottom, middle. I'll go backwards a little bit. And then a pretty curve.
We're bad at making curves.
Just try.
I made an okay curve.
These are not curves.
Try not to draw straight lines.
Yo, those are drippy. I'm not a straight nose. That's okay.
It says you.
Not according to your grandma.
You barked with
It's not what your grandma told me.
Stop.
These are your secrets.
The way
He
you
is
remember
CIA
that
agent.
actually.
That was like last week.
No, it's not. That was like 10 million years
Yeah,
ago.
can you sharpen my pencil if I give you 2
2 weeks max.
in memories?
I'm not homosexual.
You hit him in.
Please look at this. Do we have to
That's
put
what
a
it felt.
Yeah, yes. Oh, actually,
Where's this camera? Why did the arrow stop right there?
you do need to go through at least one period, so that means you do have to get out to 2 pi.
Alright, babe. Bro, it looks like
Alright, are we good on sine? Can I float away here?
Totally don't get cosine.
Okay, number 2 is cosine. I'll go ahead and draw it again, but
Go away, I don't like the word.
Why are you looking at that?
Oh, are you a
So
demon?
we're not
what?
saying the domain range.
well, I was gonna do it on this one. They're the same, so.
No.
Okay, so where did cosine start?
It starts at the 1.
Starts at the top.
Crazy.
Can't wait to meet you.
So that means if you're at the top, the only way to go is down. Down, down,
You are correct.
middle, top. Okay.
Please stop.
It's so funny.
No, mentally ill people. Like,
Never stop, Lisa.
Hope, do you sympathize with mentally ill people in the class?
No.
I'm happy for you.
You know, I'm so glad I can have one supporter.
Bro.
How do you do it so fast? Can you not?
I'm a pro.
I have the number 2 written down.
I wrote down number 2.
Don't do that. This thing won't work.
I support you. It's supposed to be different in this class, remember?
I was just singing something that shouldn't have been.
No, you were not.
She was being kind. So I was lonely. Being surprised I didn't like you.
Bro.
Yeah, Mr. Jordan. Mr. Jordan's cool. Good name.
Who's it?
Shannon?
Like not me.
Do it like that. Mine just look like really weird.
I don't know. I guess practice over time.
I didn't
Always.
start.
It's pretty
At
common.
least 20 more minutes. Yeah, honestly.
I mean, that's not. I've seen a lot worse.
No way. Yeah, well, I still.
I mean, if Katie was here, it'd probably.
This would be like,
Caden's would probably just be like
Kids,
this.
Yeah.
He's probably gonna watch
That's
this on
mine.
video.
Mine looks like that.
mine kind of looks like that.
Dude, mine
It's
looks
like,
exactly
it's like half of that and then
Yeah.
the other part is normal.
Well, just look at like number 3. That's what they're supposed to look like. Okay.
Wait. I need you to stop. Wait. You need to stop.
I'm not moving on, but I do want to talk about. They did ask for domain and range. I kind of skipped that on number 1.
Bro.
But they are the same, so we'll just talk about it once and then move on. I don't really care as much. What is the domain for these graphs?
Oh. Two.
Okay, domain is x values. So what x values are we using?
All remember.
Yeah, all of them. So that is all real numbers. I want to kind of mention this because a lot of I feel like most textbooks don't use this, the all real numbers thing. They say like I didn't use this, and I don't think like Bartlesville uses it. I used something like this when I learned it. This means from negative infinity to positive infinity. That means like everything. Or if you want to say like bigger than 2, you would write like 2 to infinity, like that. Anyways, so if you guys see that in college or something.
What?
Okay. The other question they ask is what is the range?
Two.
Y values. What Y values are we using? The lowest is -1, the highest is 1. So how do we write -1 to 1? We put -1 is less than or equal to Y is less than or equal to 1.
What's the difference?
So the other method of writing that would have been -1 to 1. The brackets means -1 and 1 are included. Okay, but our book does this, so we're going to write that. Okay, you don't have to put it on number 1, we'll just write once,
Does
yeah.
the other one look the exact same as that?
Almost.
What's different?
What's the difference? Sine starts right here and goes up.
Come on.
You know, yesterday
Okay, number 3. This is not graphing. 3 through 10 is not graphing. State the amplitude and period. You guys remember what I said amplitude was? How far does it go up and down from the middle? So on number 3, you gotta look closely at the graph. How far is it going up or down? 3. Because if you look at their graph, they put a 2 on that first line. So what's between 2 and 4? 3. So I'm just gonna put A equals 3 for amplitude. Okay, slightly harder question. What is the period? How far does it get before it starts repeating itself? Okay, 2 pi. Did they color that a different color? Yeah, they did, didn't they? I didn't even notice that. Is it kind of like purplish?
Blue.
Oh, maybe they just did my book.
You silly goose.
Yeah, my book's different than your guys'. My book, they kind of colored the period part, the part that looks like they made a different color. So because this is one period, this is how long before it starts repeating itself. Yeah, it goes from 0 to 2 pi. So it's just like our other graphs. The period is 2 pi. The graph is kind of on top of it, but yeah. Okay, number 5. What is the amplitude? How high and low does it go? 4. By the way, the amplitude is never negative. You just put 4. Okay, the period. This one's a little trickier because you can't quite see the edge of the graph where it looks like the middle of the graph. So how could we find the period? Where it starts doing what it was doing before, then that's where it starts repeating. So on 5, there's a couple places you could look. I would probably usually I look at the top of the hills. If you look at the left hill, it's just to the right of negative pi. You guys see what I'm saying? The top of the left hill is just to the right of negative pi. And then if you go to the next hill, that's just to the right of 2 pi. So that's how long before it starts repeating itself. So how far is it from negative pi, negative pi to 2 pi? How far is that? It's 3 pi. It's like how far is it from negative 1 to 2? That's 3. If you're not sure, you could subtract, like what's 2 pi minus negative pi. But yeah, that's a 3 pi gap right there. So on 6, you could look at the bottom of the valleys. Like on the left, the bottom of the valley is at negative 2 pi. On the right, it gets to the bottom of the valley at positive 2 pi. So how far is that from negative 2 pi to positive 2 pi? Okay, 7. All right. This is matching. We gotta say which graph goes with which. So on 7, they kind of started with the hardest of the group, I think. Sine of 2 theta. What did I say happens when you put a 2 in front of the variable? It's a horizontal squish. So instead of a 2 pi period, we're looking for a 1 pi period. Okay, it almost looks like, oh yeah, and sine should, in the middle, what should sine look like? Start at 0. So that could be E, could be A. What's the difference between E and A?
Like if it's like
Okay,
it's on the
E, the amplitude is 2. A, the amplitude is 1. What do we want our amplitude to be? No.
1, 0.
Right. Okay, there is no number out here, so it's not gonna be twice as tall. So the amplitude we want is just a of 1. So we actually want A for number 7.
Take that.
What?
Okay.
I don't even
E is like the second closest answer. The only problem is the amplitude is 2. Okay, number 9.
It's a big brain strategy. Though.
I probably will just have you graph a couple of them rather than matching. I don't remember, but that's what I would guess. Okay, number 9 is a cosine. So where's cosine supposed to start? At the top, yes, at 1. So is the amplitude going to be anything different? Okay, no. If there's no number in front of cosine, okay, the amplitude's just going to be the 1. Just like we started with. If they put a number out here, the amplitude is whatever this is. It'll be 3 times taller. Amplitude would be 3. So if they don't put a number out here, the amplitude is just a 1. So we want starting at the top and the amplitude to be 1. And what's the period going to be? Same thing as last time. Instead of a normal 2 pi period, it's 2 pi divided by 2. So we want the period to be pi. So cosine starts at the top, amplitude is 1, and the period should be pi. You guys see it? I think somebody said it. Are you saying B or D? D. Yes. D is cosine because it starts at the top. The amplitude is 1, and the period is pi. How about
Stop.
let's just do like 11 and call it good for today.
Bro, you're embarrassing me. Stop talking. Please stop.
Because you thought about it. Like, you stopped what you were doing.
Okay, actually I want to talk about 12 too while we're here.
It's the funniest thing on the
Stop
planet.
talking. You're not
Okay.
anymore.
So, they put the 4 in different places on 11 and 12. What is this 4 going to do to our graph? Makes it taller. The amplitude is 4. Okay, when you go to graph, here's the thing. You can kind of cheat in a way. Because remember how I was marking this as 1 even though that's like 2 off? You could call it whatever you want to. So we could call this 4. Or maybe we could call the normal 4 also though. Anyways.
You should just read
You're
your own
literally
work.
bullying me so hard.
Because you thought
You know
about
what
it.
he said here? So you know the
I know.
Bible quiz, the Bible quiz, the
Oh my God.
bonus, you know her was Nisi? I told her the day before, I was like, she's gonna give you a new one. I spelled it out for her, and she goes,
Okay,
the bonus I told her, no, I put Reese.
so the amplitude is 4. What's the period going to be? Well, they didn't put anything right there, so what's the period normally?
Pi.
2 pi.
2 pi.
2 pi is the normal period. So on your 4th mark out here, you need to call it just like we did on 1 and 2. Just put a 2 pi out there. I'll do a couple backwards. So it's gonna look very similar to number 1. You do need to mark your graph. Well, if if you're going up to 4 like normal, you don't really need to put a 4 here. I would allow that, but you do need to say this is 2 pi out here. Anyways. Okay, where does sine start at? Starts at 0, going up. Up is a little bit higher on this one.
Because I can see it in my mind.
Stop. This isn't funny. You literally embarrassed me.
You know what time my shoe is?
Please stop talking.
If you look at
Please stop talking. Stop laughing. Bro, it's not funny anymore.
And you're cooking.
So they're bullying me. Tell them to leave.
Stop. Bro.
She's just like a touch.
All right. On number 12, what is going to be different? Okay, shh, hush. What's the amplitude going to be?
0.
1.
Pi.
So it's only going to go up to 1, just like number 1 and 2. Okay, what's this 4 going to do to it, though?
It's trying to
Make it
prove my
rich.
shit.
Everything's going to happen 4 times faster. So the period, instead of being 2 pi, is going to be what?
Half.
2 pi over divided by 4. Or, right, half a pi, or the way we wrote it yesterday is pi over 2. So you don't really need to change your graph, except for instead of putting 2 pi on your period mark, you would need to put pi over 2 right here. I'm not going to make you figure out what all these are. This would be like pi over 4, pi over 8. Yeah, anyways, you can just put pi over 2 right there, it's fine.
Do we have to do the state the amplitude and period of each function?
Oh yeah, they did ask that, didn't they?
We shouldn't have to do that. Do you have
Is
to-
that what you were asking?
Yeah.
Yeah, let's do that. What's the amplitude on 11? It's
4.
easy peasy. Amplitude is 4. What's the period?
Pi.
Well, I erased it. But what was it?
Pi.
2 pi.